Understanding why certain factors cause reactions to speed up or slow down depends on collision theory. Collision theory makes a few assumptions. The first one is that molecules are in constant motion with frequent elastic collisions. What it means for a collision to be elastic is a term used in physics to mean that kinetic energy is transferred between molecules and there's no loss of energy when things collide. The second thing is that average kinetic energy is proportional to temperature. Temperature in this case would be in Kelvin. Kinetic energy is a measure of how fast a molecule is moving. We don't need to worry about the kinetic energy formula here, but kinetic energy, it is worth knowing, depends on the mass of the particle and its velocity squared. So if I increase the temperature, then I would expect to have an increase in kinetic energy as a result. And then I would have a resultant increase in velocity. The mass of a particle won't change. There are some implications here that are important to understand. One of these things is that all the molecules in a container at the same temperature have the same average kinetic energy. So suppose I have hydrogen and CO2. And they're both at 300 Kelvin. At 300 Kelvin, I would find that the kinetic energy of each particle is the same. So if I asked you which one had more energy, they have the same energy because they're at the same temperature. However, if I look at their masses, which I can look at indirectly from their molecular weight, this has a molecular weight of 2, and this has a molecular weight of 44. Since kinetic energy depends on mass and velocity, it will follow that the one that's lighter will be faster to have the same kinetic energy. Heavier will be slower.